Yes. So, anybody have doubts in the last class? If so, first we will look into that and then we will continue. Okay, shall I continue?
Yes,
Sir,
sir.
Okay then, thank you.
sir, yesterday due to signal problem in the middle of the class I had left, sir. So will you please tell, sir? Will you
I will
please
try to
repeat
brief it out. Try
yesterday's?
to brief it out anyway.
Okay.
So, when two waves are traveling simultaneously in a wave medium, two or more waves, two is a minimum number. There may be more than two waves are also there. So when these two waves or more than two waves are traveling simultaneously in a medium, that means they are traveling in same direction in same medium. Then there is a probability of getting superposition. So what is this superposition? Superposition is nothing but overlapping of displacements of individual waves and results into a new wave. So this is what we are calling superposition. So the superposition principle in fact states that the displacement of a resultant wave is the vector sum of displacements of individual waves. That means you can observe in this video diagram, two waves are there. These two waves are traveling simultaneously in the same medium, and y1 is the displacement at a given instant of time for the first wave, and y2 is the displacement of the second wave at the same instant of time. Then when these two waves are getting overlapped or superposed with each other, the resultant displacement would be y1 plus y2. That is what actually principle of superposition states. So in that also we mentioned earlier that when the crest of the first wave falls at the crest of the second wave, that means crest is nothing but the maximum displacement point in the wave, and simultaneously this is also the maximum displacement for the second wave. In that case the resultant amplitude or the resultant displacement will be maximum. When crest falls at the crest, you can observe here, when the crest falls at the crest, we cannot say whether it is always possible or not, because that depends on the frequency of the particular wave under consideration. Okay. So this is what the resultant will be. You see, when y1 and y2, you can observe here number of waves are representing. Anyway, two displacements are specified. But for all the waves, the crest falls at the crest, and the resultant wave will be like this. That means the displacement will be maximum. Okay. So this is before superposition of the wave, and this is the after superposition of. Let me join some more people. Okay. So when the crest falls at the crest, you will get maximum displacement. So this is the resultant wave on your right side. You see, the other case is when the displacement is maximum in one wave and minimum in other wave. That means when the crest falls at trough, trough is the minimum displacement point in the wave. When this happens, the resultant displacement will be minimum. You can see this is before superposition. So the waves are traveling simultaneously like this. In this case, so this is the y1. That means this is the trough of the first wave. Falls at the crest of the second wave. So in this case, the resultant wave displacement will be minimum. So after superposition, the wave is like this. Okay. So now the actual case comes in. So when the crest falls at the crest of the second wave, it results maximum displacement, and this case is referred to as a constructive superposition. Why you are calling it is constructive? Because the displacements are being added up. So that's why it is called constructive. So therefore, the resultant will be maximum. So on the other hand, when the crest falls on the trough, the resultant displacement will be minimum. This is called destructive superposition, where the displacements will be subtracted from one another. Okay. Okay, this is called destructive superposition. In this case, the crest of the one wave falls at the trough of the other wave, so the resultant displacement will be minimum. That's why it is called destructive. Okay.
Sir,
Following,
could you please repeat it again?
which one destructive? So when the crest falls on the trough, crest of the first wave falls on the trough of the second wave, the resultant displacement will be minimum, because the displacements will be subtracted from one another. So the resultant will be automatically having a minimum displacement. So that's why it is called destructive superposition. Now coming to the phases. So somebody please mute your mic. All of you please mute your mics. So when it is necessary, you can unmute yourself. Still people are joining. Let me join them. Now, so the first case, that is the constructive superposition. When the crest falls at crest and trough falls at trough. In these cases, the phases will be equal for both waves. So if you observe here at this point or at this point, if you start from here to here, if you consider this as a one complete cycle, this is the one complete cycle. From here to here, here to here is the one complete cycle. Or you can consider that from here to here also one complete cycle. One complete cycle always gives you 2 pi radians of phase. Okay. So when the trough falls at the trough and crest falls at the crest, they are having the same phases. At the same instant of time, they are having same phases. Therefore, the resultant phase difference will be 0 in case of constructive superposition. That's what actually they are showing here. You see, in this case, there is a phase difference. So the phase difference occurs because the crest falls at trough. In case of destructive superposition, జరుగుతున్నప్పుడు ఫస్ట్ వేవ్ క్రెస్ట్ దగ్గర సెకండ్ వేవ్ ట్రఫ్ కానీ లేదా వైస్ వర్సా, ఫస్ట్ వేవ్ ట్రఫ్ దగ్గర సెకండ్ వేవ్ క్రెస్ట్ కానీ ఇన్సిడెంట్ అవుతున్నాయి. That's why the resultant will be having a minimum displacement. Therefore, the phase difference will be always an odd integral multiple. Odd integral multiple అంటే odd numbers multiple కింద ఉంటున్నాం అంటే 1, 3, 5, 7 and so on. These are the odd integers. So the phase difference will be odd integral multiple in case of destructive superposition. But in case of constructive superposition, the resultant displacement will be 0. Constructive లో 0 ఉంటుంది, destructive లో odd integral multiple కింద ఉంటుంది phase. So you see, so then you may ask, what actually happens when two waves are superpositing with each other? Both having the equal probabilities. That means taking place of constructive superposition or destructive superposition, both having the same probability. Okay, so see. So the behavior of these waves can be modified depending on the amplitude and frequencies. So the probability of occurrence of constructive superposition or destructive superposition or both, because as the frequencies are changing, the superposition may also change. So the resultant of these constructive and destructive superpositions is referred to as interference. Interference of waves. What actually happens when interference takes place? So superposition is the actual principle that results into interference. When interference takes place, the resultant displacement will have an alternating values. That means alternatingly maximum and minimum displacements will be recorded. So you see the definition of interference of waves. So this is actually superposition of waves from the sources which are producing the waves of same frequency and same amplitude. So what is the physical effect we are encountering while interference is taking place? The physical effect we are observing while interference is taking place is variation in displacements, change in displacements. The displacement is becoming maximum when it is constructive, and the displacement is becoming minimum when it is destructive. Okay, this is the physical effect that is taking place during interference. You see, you can see here continuously the waves are traveling simultaneously and they are getting superposed with each other, which results into interference of the wave. So here R is the resultant amplitude, that is the maximum amplitude. You see. So the waves are getting superposed as they are traveling through the medium. So interference is treated to be as a special case of superposition of waves which are generating from two different sources, usually having same frequency and amplitude. Of course, every time you are mentioning same frequency and same amplitude, This is only to make the mathematical analysis simplified. Okay. So now this after this visualization, to get an understanding, we will move into the theory portion. That is the mathematical part. The mathematical portion has to be handled out. So the initial mathematical portion is nothing but we will simply substitute the values of y1 and y2 in the resultant displacement equation. So you will simplify them to obtain conditions for maximum displacement and minimum displacement. So that is nothing but maximum amplitude and minimum amplitude, because amplitude is nothing but square of displacement. So you know that the amplitude is actually directly proportional to the square of the displacement. See, if displacement is maximum, obviously amplitude will also be maximum. So now you will see the mathematical description which involved in this superposition and thereby causing the conditions. You see, so this is the condition that can be prevailed during the superposition. Here are the definitions given by theorists to provide you a better understanding. You can see the first definition itself. When two or more waves, so this is what we are calling you see, when two or more waves having same frequency, this is for a mathematical simplification. And once again mentioning you, the frequency need not to be equal, but for our convenience, mathematical convenience, we are choosing same frequency and a constant phase difference. That means the phase difference between the two waves that are superpositioning with each other must have a constant phase difference. The constant phase difference may be 0 or a non-zero value also. Constant phase difference ante enti. When two waves are traveling simultaneously, the phase difference between these two are supposed to be maintained a constant relation. A constant relation 0 అవ్వచ్చు లేదా నాన్ జీరో వాల్యూ కూడా అవ్వచ్చు. బట్ ఫేజ్ డిఫరెన్స్ అయితే మాత్రం డెఫినెట్ గా కాన్స్టెంట్ గా మెయింటైన్ చేయాలి. ఫేజ్ డిఫరెన్స్ కాన్స్టెంట్ గా మెయింటైన్ చేయలేకపోతే సూపర్ పొజిషన్ జరిగే ఛాన్స్ ఉండదు, ఇంటర్ఫిరెన్స్ జరగదు. ప్లీజ్ రిమెంబర్ దట్ పాయింట్. దిస్ ఈస్ వెరీ వెరీ ఇంపార్టెంట్ పాయింట్. It should be having a constant phase difference. Then the intensity or the amplitude of the light should be modified. So the displacements ఏమవుతున్నాయని చెప్తున్నాం మనం ఇప్పుడు. ఇందాక చూసిన వీడియోలో చూసినప్పుడు ఏం చేస్తాం, డిస్ప్లేస్మెంట్స్ కన్స్ట్రక్టివ్ జరిగినప్పుడు మాక్సిమం డిస్ప్లేస్మెంట్ వస్తుంది, డిస్ట్రక్టివ్ జరిగినప్పుడు మినిమం డిస్ప్లేస్మెంట్ వస్తుంది. సో maximum and minimum displacements are corresponding to maximum amplitude and minimum amplitude. So these are corresponding to maximum intensity and minimum intensity. Okay. So the intensity is directly proportional to square of the amplitude. So the intensity is modifying. That means the resultant wave after interference is exhibiting change in intensity. That is, the intensity is being modified. Okay, the modification of the intensity of light due to superposition of waves is called interference. So this is the actual definition we need. So please note it down. So a highlighted portion ఏదో ఉందో అది note చేసుకోండి. The modification of intensity or amplitude of light due to the superposition of waves is called interference. Okay. The definition should be clear and straight to the point. So this will be very much helpful for your Viva OS examinations. You need not to by heart pages of pages. The point should be straight to the point. Okay. So that means after superposition, the intensity or amplitude of the wave is getting changed. So this is what you are calling interference. And coming through that, how these distributions will be taking place. And the resultant amplitude is sum of the amplitudes of the two waves. Already you specified it earlier. When crest falls on the crest, the displacement is being added up. So that is what actually here they are again stating. The resultant amplitude is sum of the amplitude of the two waves. Then the interference is called constructive interference. When the resultant amplitude is difference of the two amplitudes, then the resultant interference is referred to as destructive interference. Okay. So the resultant pattern appearing on the screen. So on the screen altogether you can see a distribution of intensity. Intensity distribution ఎలా కనిపిస్తుంది మీకు pattern లోని అంటే depending on the source you considered, what kind of source you have chosen. మీరు monochromatic source తీసుకున్నారా, polychromatic source తీసుకున్నారా? So I will tell you the difference. Monochromatic sources are the sources which can generate ideally single wavelength. Okay. Whereas the polychromatic sources, they can generate multiple wavelengths simultaneously. So for interference experiments, it is always suggestible to use monochromatic source for experimental purposes. So because monochromatic source can generate single wavelength, therefore the mathematical simplification can take place if you consider one wavelength. So if you consider, say for example, we considered a monochromatic source. So this is generating a single wavelength. Let us assume that. Then what will be the interference pattern that is appearing on the screen? How it would be looks like? It looks like an alternating patterns consisting of bright and dark regions. Listen carefully. The pattern consists of, అంటే స్క్రీన్ మీద మీరు అబ్జర్వ్ చేసే ఇంటెన్సిటీ డిస్ట్రిబ్యూషన్, ఇంటెన్సిటీ మారిపోతుంది అని చెప్తున్నారు కదా. 2 or more waves ఒకదాంతో సూపర్పోజ్ అయినప్పుడు ఇంటర్ఫిరెన్స్ జరుగుతుంది. ఇంటర్ఫిరెన్స్ జరిగినప్పుడు మీకు ఇంటెన్సిటీ డిస్ట్రిబ్యూషన్ జరుగుతుంది. ఈ ఇంటెన్సిటీ మోడిఫికేషన్ జరుగుతున్నప్పుడు ప్యాటర్న్ మీద చూస్తున్నప్పుడు మీకు ఎలా కనిపిస్తుంది అంటే, స్క్రీన్ మీద చూస్తున్నప్పుడు ఆల్టర్నేటింగ్ గా బ్రైట్ డార్క్ రీజియన్స్ కనిపిస్తుంది. అంటే ఒక బ్రైట్ ఇమీడియట్ గా ఒక డార్క్, దాని పక్కన ఒక బ్రైట్ ఇమీడియట్ గా ఒక డార్క్. ఈ టైప్ లో మీకు కనిపిస్తుంది ప్యాటర్న్ మీరు అబ్జర్వ్ చేసినారు. And coming to the conditions for the interference, so this is another important topic. The condition for the interference, in these conditions, so the first and foremost important condition is the two sources should be coherent. So what are coherent sources? So when the phase difference between the waves generating by the sources have a constant phase difference over a period of time, then it is called coherent sources. I will explain it. మీరు ఇప్పుడు రెండు సోర్సెస్ తీసుకున్నారు, సే S1 and S2 sources are there and they are generating waves continuously. The phase difference between these two waves generating have a constant phase difference. ఆ phase difference జీరో అవ్వచ్చు లేదా నాన్ జీరో వాల్యూ అయినా పర్వాలేదు, ఇందాక చెప్పాం ఆల్రెడీ. జీరో అవ్వాలని రూల్ ఏం లేదండి, కాన్స్టెంట్ ఫేజ్ డిఫరెన్స్ అని మెన్షన్ చేస్తున్నాం. కాన్స్టెంట్ ఫేజ్ డిఫరెన్స్ అంటే అపార్ట్ ఫ్రమ్ జీరో నాన్ జీరో కాన్స్టెంట్స్ కూడా ఉండొచ్చు. అంటే ఫర్ ఎగ్జాంపుల్ ఫస్ట్ వేవ్ అండ్ సెకండ్ వేవ్ మే హ్యావ్ ఏ π/2 రేడియన్స్ ఆఫ్ ఫేజ్ డిఫరెన్స్ యాజ్ ఆఫ్ నో. అంటే ఇప్పుడు మెజర్ చేసినప్పుడు π/2 డిఫరెన్స్ ఉందా. ఆఫ్టర్ సమ్ టైమ్, say after 1 minute or after 2 minutes, the phase difference should also be π/2 only. 2 నిమిషాలు పోయిన తర్వాత మీరు మెజర్ చేసినప్పుడు కూడా phase difference between these two waves should be π/2 only. Then those sources are called coherent sources. అలా కాకుండా ఈ నిమిషంలో phase difference π/2 ఉంది, నెక్స్ట్ మినిట్ లోని ఫేజ్ డిఫరెన్స్ మారిపోయింది అనుకోండి, సే 3π/2 ఉందనుకోండి, దెన్ దోస్ సోర్సెస్ ఆర్ నాట్ కోహరెంట్, దే ఆర్ కాల్డ్ నాన్ కోహరెంట్ సోర్సెస్. రిమెంబర్, నాన్ కోహరెంట్ సోర్సెస్ కెన్ నాట్ ప్రొడ్యూస్ ఇంటర్ఫిరెన్స్. అందుకనే ఫస్ట్ కండిషన్ అదే మెన్షన్ చేస్తున్నారు మనం ఇక్కడ. ద టూ సోర్సెస్ షుడ్ బి కోహరెంట్, కాన్స్టెంట్ ఫేజ్ డిఫరెన్స్ ఉండాలి. కోహరెంట్ అనగానే మీకు వెంటనే స్ట్రైక్ అవ్వాలి, కాన్స్టెంట్ ఫేజ్ డిఫరెన్స్ ఉండాలి. అండ్ అఫ్ కోర్స్ ఈ రిమైనింగ్ అన్నీ కూడా ఏంటంటే ఎక్స్పెరిమెంటల్ లిమిటేషన్స్ ఉన్న కండిషన్స్. ఫ్రమ్ 2 to 8 the two sources must emit continuous waves of same wavelength and same frequency. The same wavelength and same frequency తీసుకోవడానికి కారణం చెప్పాను ఆల్రెడీ మీకు, మ్యాథమెటికల్ సింప్లిఫికేషన్ గురించి. మోర్ ఓవర్ ఏంటంటే దే మస్ట్ able to emanate continuous waves. అంటే బ్రేక్ ఇస్తూ వేవ్స్ ప్రొడ్యూస్ చేస్తే ఇంటర్ఫిరెన్స్ ప్రొడ్యూస్ అవుదాం, మస్ట్ బి కంటిన్యూస్. నెక్స్ట్, ద డిస్టెన్స్ బిట్వీన్ ద టూ సోర్సెస్ షుడ్ బి స్మాల్. అంటే S1 అండ్ S2 రెండు సోర్సెస్ తీసుకున్నాం అనుకోండి, ఈ S1 అండ్ S2 మధ్య డిస్టెన్సెస్ ఒకేలా తక్కువ ఉండాలి అంటున్నారు. And for example, you see, S1 ఇలా ఉందనుకోండి, this is the source, point source, and S2 is here. Is another point source. ఈ డిఫరెన్స్ అండి ఇక్కడ D అని మెన్షన్ చేస్తున్నారు కదా, ఇక్కడ D అని మెన్షన్ చేస్తుంది ఏంటంటే సోర్స్ 1 అండ్ సోర్స్ 2 మధ్యలో ఉన్న సెపరేషన్ ఎంత ఉన్నది, ఇది మీకు D అవుతుంది. అది తక్కువగా ఉండాలి అంటున్నారు. అంటే S1 S2 మధ్య డిఫరెన్స్ బాగా ఎక్కువగా ఉంటే కనుక you cannot observe interference. And then the distance between sources and screen should be large. ఇది సోర్స్ మధ్య డిస్టెన్స్ అండి. మీకు స్క్రీన్ somewhere here, you may place here the screen. So this is called capital D, the distance from the source to the screen. This is the screen. Okay. Of course, to use the interference fringes, the background should be dark. This is a laboratory requirement. Interference produce avడానికి requirement ఏం కాదు ఇది. And the amplitudes of interference waves should be equal. Already mention చేసాం మనం అది. Sources must emit continuous waves of same wavelength and same frequency అన్నారు. సో amplitudes కూడా ఈక్వల్ గా ఉండాలి అని చెప్తున్నారు. ఇది కూడా mathematical simplification గురించి. And of course sources must be narrow, extremely small అంటారు. అందుకని చెప్పాను కదా, the sources should be of ideally point sources. Point sources is however an ideal concept anyway. So theoretically we will choose point sources only. Next, the sources should be monochromatic. Of course this is also laboratory limitation only, not theoretical limitation. Monochromatic sources మాత్రమే interference produce చేస్తాయా అంటే the answer is no. Polychromatic source can also produce interference. మీరు interference already observe చేశారండి. You have seen interference pattern in your regular daily life. You observed several times. You may not know that is due to interference. అది interference వల్ల వచ్చింది అన్న విషయం మీకు తెలియకపోవచ్చు, కానీ ఆల్రెడీ మీరు interference patterns observe చేశారు. So we have a topic known as interference in thin films. One of the most important topic. So ఆ టాపిక్ వచ్చినప్పుడు మీకు యాక్చువల్గా ఎగ్జాంపుల్స్ తో చెప్దాం అనుకున్నాం. సో ఇంటర్ఫియరెన్స్ ఇన్ థిన్ ఫిల్మ్స్, ఐ థింక్ యూ మైట్ అబ్జర్వ్ కలర్స్ వైల్ యూ ఆర్ వాచింగ్ సోప్ బబుల్స్. చూసే ఉంటారు కదా, సోప్ బబుల్స్ లోని కలర్స్ అబ్జర్వ్ చేస్తుంటారు. చూసారు కదా ఎప్పుడైనా? That is due to interference. So more specifically, interference in thin films. Okay. Next, so here are the definitions. When you already will defined it, I will share you anyway this document for your reference. So now we are moving to the mathematical analysis. So according to the principle of superposition, we will consider two waves. So you know that the waves, sinusoidal waves, sinusoidal means they may be sine wave or cosine wave. Sine wave is different from cosine wave in phase point of view, but they are look alike. Together they are called sinusoidal. The sinusoidal waves can be represented according to simple harmonic motion analysis like this. Y is equal to a sine omega t. This is the displacement of one wave. And y2 is equal to b sine omega t plus phi. This is the displacement of second wave. You see, I will explain each term in this. A is the amplitude of the first wave, and of course omega is the angular frequency and t is time. And in the second wave, b is the amplitude and omega is the angular frequency and t is time, and phi is a phase between these two waves. Here they consider different amplitudes A and B, you can observe here, but taking the same frequency. Omega and omega, they are taking same frequency but different amplitudes. Two waves have a phase difference of phi. Now according to the principle of superposition, you know that the resultant wave amplitude should be y is equal to y1 plus y2. Yesterday we specified it. Y is equal to y1 plus y2. Now you substitute those values here. A sin omega t plus b sine omega t plus phi. A small trigonometric expansion. You see, sine omega t plus phi is like sine a plus b. So is being expanded sine a cos b plus cos a sine b. So the equation becomes like this. Now, from this term, from the first term and the third term, you observe from the first term and the second term, there is a common parameter sine of omega t. So take the common as a common factor sine omega t. So it results into a plus b cos phi sine omega t plus this third term is written as this. Okay. I think up to here, no issues, isn't it? Up to equation 2,
Yes, sir.
yes. Then we will introduce a plus b cos phi as r cos theta and b sin phi as r sin theta. Okay. So that means we can replace these parameters into this equation. So where r is the resultant amplitude and theta is the resultant phase. That means after superposition. R is the amplitude after superposition and theta is the phase after superposition. Now square equations 3 and 4 and add them. Equations 3 and 4 square chesi add change. You will get r square cos square theta plus r square sin square theta and b square sin square phi a plus b cos phi whole square. So you are expanding that, and on the left hand side you will have r square cos square theta plus sin square theta will become 1, and this a plus b cos phi whole square will be expanded, a plus b whole square, a square plus b square cos square phi plus 2ab cos phi, and of course b square sin square phi. You just go through those equations. I think you didn't have any difficulty in expanding. If you have any difficulty, please let me know immediately. Okay. After expanding this a plus b, again the second term and the fourth term have the common factor b square. So b square of cos square phi plus sin square phi, again it becomes 1. So altogether you will get r square is equal to a square plus b square plus 2ab cos phi, equation 5. I will stop here today up to r square, that is up to 5th equation. If anybody have any difficulty, let me know right now, please. Anybody have doubts up to equation 5?
No, sir. No, sir.
Is it
No,
clear?
sir.
Okay, okay. Okay then.
Clear, sir.
So we will continue from here onwards. You will just remember this equation. No problem. I will brief it out tomorrow also. It's not an issue. From this onwards, we will continue the analysis.
Okay.